Okay, so what we gotta do right now is we gotta find a point H on this segment AB, so that way we have this relation. So we gotta construct it as so. So I'm gonna just lay out these steps. I'm gonna just tell you and then we'll prove our construction. So the first thing is construct the square on AB. So to construct the square on AB, we got to know how to do that. So let's just draw that out. So we're gonna have this, and I'm just gonna eyeball it, but you're gonna need to do the actual construction of a square here. And let's say that that's the square on AB. Now we label these points C and D. And then the second thing is we're gonna do find midpoint E on AD. So to find the midpoint, right, we would need to do the perpendicular bisectors, right? We would need to open our compass to more than halfway. We would draw an arc like that, right? Let's see if it, oh, that's nice, okay. So then we would draw an arc, right, we would draw a circle with center A and just more than halfway. With that same compass setting, we would draw another one like this, right? And then we would draw the line, and then where the line meets, that point is the middle. That's the midpoint. Now I'm going to erase these construction marks, and I'm just going to sort of guess at where E is. But you would need to construct this. Okay, and then now, right, draw ED. EB, sorry, EB. Draw EB. And then what you do is draw circle E of radius EB. So now I'm gonna try my best to draw that arc, right? So it's got to be of radius EB here, and that's not the best one looking. So let's try again. Let's see if I can do it better. But again, you have to with the center is E and the radius EB, you got to draw this arc, right? And again, that's not the best. Yeah, I want to do it again. Let's see if I can do it again. Let's see if I can get better. I don't like these arcs because I do want to make it the length of EB, but I'll just try and do it like this. Here we go. Maybe like that's better. It's slightly better. But yeah, so my construction isn't going to be perfect because of the fact that I actually don't have the compass to do this. But essentially then from E to F will be the same length as from E to B. And then what we do is construct the, oh, wait, I skipped a step. So then now I have to extend AD to F from A. And then the last step is to construct the square on AF. Get H. So the square on AF, right, if I do this right, so I'm gonna draw a line going here, which is the same length as AF because I want to do a square, but you'd have to do the steps in constructing the square. And then you'd get H right here. This point is H. Now, I want to prove that this is indeed, that it does do what I need it to do. So what I do is I'm going to draw it all the way through that line. whatever we want to call this line, because we would need this point. So A, B, C, D, E, F, G, sure, G. This point is G. Yeah, and then, whatever, H, I, J, K, whatever, K. Okay, and then now I have this construction should give me that this is the case. Okay, so the first thing in this proof, in the proof of the construction, right, is to invoke that theorem where we just basically say that, you see, since it's the case that E is the midpoint, right, we have to make it so that way from our other proposition, that we should be able to see that FD or DF, FD, right, times AF plus the square on AE or EA is equal to the square on EF from previous proposition. You don't need to know the name. I don't remember the number, but previous proposition. But you need to be able to just see why this first statement is true. Now you should see that EB is equal to EF because they're both radii. So then that means that this FD times AF plus EA squared is equal to EB squared. And then if we look at EB and we know that we constructed a square here, we should see that ABE is a right triangle and EB is the hypotenuse. So now, by Pythagorean theorem, by Pythagoras, I can say that EB squared equals the square on AE, the square on AB, which is drawn there. So it's equal to EA squared plus AB squared. And then I could substitute, because now I have EB squared and EB squared. So I have FD times AF plus EA squared is equal to EA squared plus AB squared. Because that's equal to, this is equal to EB squared, and then EB squared is equal to this. So instead of EB squared, I wrote that right there. Now, after we have this relationship, we should see by subtraction, right? By subtraction, FD times AF equals AB squared. And then, now that I have that, right, you want to look at the picture. FD is this entire length times AF is the same length as AH. So if you have, so now you want to say, you want to look at these pieces. Okay, so let's look at these pieces. FD times AF is equal to, and let's call this whole piece, let's call this alpha. Alpha plus, right? Okay, so again, FD is this times this rectangle. So it's alpha plus this piece. Let's call this piece beta. Beta. And then now let's look at what AB squared is. Well, it's going to be AB squared is equal to alpha plus this piece. Let's call this piece gamma plus gamma. And then this means, right? So we know that these two things are equal. So then that means that alpha plus beta equals alpha plus gamma which means that beta equals gamma. And now you do need this last step. We need to look at what beta is, and we need to look at what gamma is. Well, beta is this square, which is clearly AH squared. And then now gamma takes a little bit longer. We can clearly see that this is HB, but BC, this length for this rectangle, is the same thing as AB because it's a square. So gamma is for sure AB times BH. And now we're done. We got the final result. Our point H does do indeed what we needed it to do.